So counting functions is something super important to be able to do, and it's actually very similar to counting sets and subsets, right? Because functions, at the end of the day, are subsets of a specific kind of set. It's going to be subsets of a Cartesian product. So it's not going to be too different from our counting problems with just regular subsets. But something to note, if we have a function f, or let me write that down in lowercase f, from, let's say, the reals to the reals, or from the integer to the integer, or from the rational numbers to the rational numbers, or any mixture of them, if we have it something from the reals to the integers, or from the rationals to the integers, whatever it may be. If we have a function from these, we actually cannot count how many functions you can have, because this set is infinite. There's an infinite number of real numbers. There's an infinite number of integers, rational numbers, and I think you get the point. The point is that you cannot count something if there's an infinite amount of it. You will never land on a number that's going to be exactly how much there is, because there's always going to be more. So when we're counting functions, we're actually going to be counting between finite functions, which is oftentimes going to be something like 1 and 2, 2 and 3, 3 and 2, right? Like this is a finite function because we have exact points. For example, if we had something like a ... here, because you never end, right? If you had something like the real numbers, the real plane, this would be just ... it would never end. You could never count it. There's no way of counting it. But when we set it to be a finite function, we let, for example, this be the subset of A cross B, and we can say A has the elements 1, 2, and 3, and B has the elements 2 and 3. Well, what do we find? We find, okay, this is in fact a function because it's a subset of the Cartesian product, but how many functions can you make out of the, how many subsets can you make that are functions here? That is actually what we're going to be solving. We're not going to be solving it for functions like this because these are infinite sets that we're dealing with. A and B here, so the function would, in this case, be from A to B. A and B are finite, so we can actually end up counting them. And this goes the same for if we had a finite function go to an infinite function. You cannot have any one of these be infinite. It's just not possible. It doesn't make sense to count an infinite number of something. So when we're doing our counting function problems, we're going to be dealing with finite functions.